Alright, so here we're going to do a little bit of a covering of Ohm's law and why this is important for building an ROV. So, you know we have a fuse. We don't want it to blow or else the entire thing's going to shut down. And we know we have this 12-volt power supply. So how can we tell if what we're running on this RV is going to draw more than 15 amps, which is the, well, that's the specific fuse we use for this, because in our case we're using these banana plugs in this, and these plugs have a 15 amp fuse built in. It's not like these other ones where we can throw in any size fuse we want. So if this goes, then we're kind of screwed. So in order to tell if we're going to take over 15 amps, we can do some quick math on this thing called Ohm's law. So Ohm's law is that the voltage you're using is equal to the current, which is shown by an I, times the resistance, which is R here. Now we can just do some easy math here and figure out that our current is equal to the voltage divided by the resistance. So this is what we want to find. We know we're running 12 volts. So we can do 12 volts over, but what's our resistance? Well, our resistance in this case are our motors. And how can we find the resistance? Well, there's these nice things called multimeters. They basically are a fancy tool here that you spin this dial and you can read different electronic components. So you can read voltage. So just to make sure that this thing is running on 12 volts, we can take this and it's falling off because the cable's too short. I'll twist it up. We can read the voltage coming out of this. So one contact there, and I'm reading. You gotta spin the dial so you read the right thing. I was currently reading resistance of that. It's not what you want. And you know what? I need to get on the right contact. There we go. This is actually reading 13 volts because it's very well charged. But in this case, 12, 13 doesn't make much of a difference. And then you spin the dial and you can read the resistance of an object. So here we've got our bilge pump. We put the leads across the two things we're going to hook our motor up to, and it comes out to 5.1 ohms.
Or 4.9.
Or 4.9 or something, I don't know. This isn't the greatest multimeter. It takes a while for it to make up its mind, and then sometimes even then it doesn't. We'll call it 5 for ease of math. 5, and then that's the symbol for ohms. Equals our current. So now we do some math on any calculator. In this case I'll just use my phone. 12 divided by 5 is 2.4. So each one of our motors is going to draw 2.4 amps. Now we have 3 of these motors. So 3 times 2.4 is going to be 9.2 amps is our total current. Now we've also going to have a camera on there.
7.2.
7.2?
Yes.
Times 3. Ah, yes. College student who has done many years of calculus, still can't do basic multiplication. It happens to everyone. So 7.2 amps is our total current from the motors, but we also have a camera. However, the camera isn't pushing masses of water, it's just filming, so it doesn't really draw that much current, and you can basically call it 0. So in this case, this is all the current that our ROV is going to be drawing at any effective time. That's if you run all 3 motors at the same time, which isn't going to be happening all the time. And obviously, that's much less than 15 amps, so there's no chance our fuse is going to blow. Oh, I've moved the camera. Okay, I think you're recording.
Okay, pulls off?
Yep.
Okay, so what is electricity? Ohm's law, current, amps, volts, it all sounds very mysterious. So let's do a simple experiment to find out what electricity is. So here is a plastic bag from produce department. And now we have a strip of plastic. And I'm going to rub the whole strip the same way. And now, abracadabra, what is happening here? Two things. It looks like there is repulsion and attraction. I'll rub it again. Today's a sort of a damp day and we're near the ocean in beautiful Southern California. There we go. So what is happening? All of this plastic was rubbed the same. When I rubbed it, I stripped off electricity and charged this plastic. So we can see that like charges repel and opposites attract. So how many kinds of electricity are there? Two at least. And what are you going to call them? Yes and no? Up and down? Well, how about plus and minus? So what is electricity? Well, the answer is this thing is made of electricity. You are made of electricity. All matter is made of electricity, and we disguise it by calling them atoms made up of protons, electrons, and neutrons. Every single thing is electricity. Now, plastic grabs its electrons and I rub them off with my fingers. But it's an insulator, it won't flow, so we call this static electricity. And it might shock you to find that this is about 20,000 volts of static electricity as shown by this great distance at which it attracts and repels. So if you want electricity to move, if you want electrons to escape atoms and wander around freely, you must have metals. So everything we have here is metal inside non-metal. The metal lets the electrons flow, and the non-metal part, you can rub it and give it a static charge, but it won't let electricity flow. So what's the answer to the question? What is electricity? And the answer is all matter is made of electricity, and you learning how to pump it around, how to measure it, helps you understand the universe and yourself. You are made of electricity. Your brain makes electricity. Your muscles work with electricity. All matter is made of electricity.